So this is how you vary your scale and your angle of rotation. So now next stage, if you could see, when you select on the object, as we had invoked this hatch object together, that is both the internal surface together, you can see these two are referred to a single hatch object. So when we, you can also see a pointer that is highlighting here. So this will control the dynamic addition of your hatch. So let us try and move this object to see how it affects. So let us select this object with the left mouse button, click and drag to elsewhere. Suppose let us say, let us position it outside here. So now once you move it outside, you can see that this single selection point now has split into two different areas. Let me select this object again. So now what you can see is, you remember this was an associative type hatch, and also we had enabled the boundaries that were selected. So now typically, let me just go back to the hatch edit to have a view. So here right now we have the option to display the boundary of this. So now when we click on that display boundary, now you can see the boundaries of the respective hatch. We can use this dynamic to edit to modify the hatch boundary. So now assuming, let us click and drag this, that is we are reaching essentially the stretch command that applies to this object. So once we position on to this, as the object was already in an associative manner, so whenever the boundary gets changed, your hatch also gets extended to it. But right now this hatch is not associated to any object, so that's why you can see the current associated object is not highlighted. So it means this hatch is independent and is not associated to any object, but rather it is just enclosed by the object. So suppose if you want to recreate the hatch based on the boundary, so now you can click on this recreate option. So once you click on the recreate option, it will try to ask like what type of boundary that should be selected. It should either be a polyline type of boundary object or a region type of boundary object. So when you select the polyline type of object, and then the next requirement is a yes or no boolean type of requirement, whether the hatch should be associated with the new boundary. That is, we are redefining the boundaries as well as the hatch object. So once we do this, we are selecting the command as yes, y, and then selecting it. Now the associative and other commands get alerted because now the hatch is recreated with an object boundary. So now if you select outside and then click on the properties, you can see there we have a hatch, and then also we have a polyline object, because this polyline object is what we created using the recreate object. So this is the looking into how the hatch edit properties of associative and modifying the boundaries will affect. So next what we have is, suppose if you want to remove the boundaries of a given hatch, then you can click on this remove boundaries object and select which object the boundary has to be removed. So towards this, you can't select the hatch, but rather you have to select the boundary. So suppose if you're selecting this boundary, now the associated hatch is removed. That is, we right now have only the hatch and the boundary that has defined was removed. So it means that the hatch right now is without a boundary but still enclosed within the object. So now let's look into the next topic, that is the island detection. That is how AutoCAD can identify two different objects that are included within a larger boundary and decide upon which object or the boundary to be selected and how the hatch should be applied. So towards that, let us draw a simple shape. So let us try and draw a polygon with 6 sides with this center, and then circumscribe about a circle, assuming the radius to be 45, right? So, and then we'll try and position a circle of approximate dimensions like this, and then again position it outside within a rectangular boundary. Consider something like this. So now let us invoke the hatch option, and so now we'll go into the settings to look into this island detection option. So now this is in the enable condition, that is AutoCAD will try to identify separate object zones within the given object. So now if you could see, right now it's in the normal island detection methodology. So now let's see how it does. So when we pick the points, the first internal point, if we pick in this, and next, as you could see, once it is selected, the island is detected that there is a separate object enclosing within a secondary layer. So by that, the polygon has been identified as an island and the same hatch pattern has been applied. So this is your property of setting the island to be a normal detection. Suppose if we select this outer, then only this has been applied. You can see dynamically the selection is getting updated. Whereas if we select the ignore option, then it ignores the complete object and then run the hatch throughout. So this is the key differences between the three island options that we have. Suppose if we did remove this, then the software does not look for any island detection and only those internal boundaries specifying to the requirement will be selected. So this is the island detection option that goes into. So just quickly summarizing the different options that we had made is, we had looked into the type and pattern of the hatch and then also looked into the angle and scale of it. So based on the requirement, we can first go in and then also we can edit as per the modification, and then the origin requirement is there. Suppose if you want to move the origin or you are working around a non-linear boundary, then if you want to specify the separate origin point, then you can make use of these to position it. But rather if you have a well-defined object boundary, then this might not be an applicable option for you. That is, it will identify the object boundaries and set in hatch directly. Next, you have the option to select from how you are going to define the boundaries, whether you are going to pick an internal point or select the object directly, and then once you have applicated it, whether you have to remove the boundaries, that is, you remove the boundaries as a separating object, that is, consider only the hatch alone. So in that case you can do it. And suppose if the hatch boundary has been modified, that is, the object has been taken away, then you can recreate the boundary to create a separate object files enclosing the hatch. Next, we can also view like what is the selected object, current object wherein the hatch command has been done. So this is your view selections option. Next, we have different options to select how the hatch needs to be propertized. So that is, first, to make it annotative, that is, the annotative properties get applied to this hash. So whatever global level annotation update you can make can be applied to here. And next, you have an associative property, that is the hatch associating with the object boundary. Next, the option to create separate hatches if you have complicated object. Next, again, where the hatch should be positioned, and again with respect to the layers. So then we had looked into the different island options. So these are the key areas that is typically looked at. So we'll see a unique case where if the object is not a closed one but rather an open one. So in order to demonstrate, let us look into a open-ended object. So let us consider a line that approximately of length 190 mm through, or typically a square. But consider the third edge is short of completion, that is, it's an open-ended object, it's not an enclosed one. So in that case, if you try and invoke the hatch option and try and pick the internal point, you will get a AutoCAD warning message saying that a closed boundary cannot be detected. So what it says that there might be some internal gaps within the object, or the selected area, the boundary object must be outside the display area. It is highlighted by using two red circles, and if you want to remove it, we have to rectify it and then use the redraw or region command. You can also see it, AutoCAD suggests certain options to remove this. That is, one thing, to zoom to the maximum limit onto that and check whether it's actually closed or not, and then choose a specific boundary that can help us. And suppose if the object is still open, then come out of the hatch command and then use the extend or the stretch commands to close the object, and then specify the object boundary. And then the third point is to check whether the plane of reference is the correct one and you have an enclosing object. Whereas the fourth one, if in case of open-ended objects, if the precision is not needed, then you can use the gap tolerance setting that we have. But there's a hack to it. Sometimes gap tolerance effect might not serve as intended, because if you want to change it, you can change in this option menu, wherein you can have a slider. The size varies from 0 to 5000. That's the maximum units of gap tolerance that can be specified. But consider that object to be a closed one and then try and impact. So in certain cases, even if we give a gap tolerance and then give it, it might not detect. So, but you can, instead of going for the gap tolerance, you can very well overcome the situation by using the object selection command. So even with no gap tolerance, you can still select the object, the boundary objects within which you can denote the closed area. So now you can see, based on the selection, the hatch is applied, and this is for how it varies. So this done with the hatch command. So we can also have a quick overview of the hatch toolbar, wherein if we want to edit this property, then we can use one of these drop down menus or the selection menus to change the properties without going into the hatch edit command. So here again you have the different options that we have: the hatch transparency, the angle of the hatch, and then again the pattern scale. Then also we can set and change the object origin. So this will, changing an object origin will change the hatch reference. Suppose if we select a random point like this, say this, okay, suppose if the origin point is set to be this, and hence the hatch will get allotted accordingly. That is, if considering that start point to be here and the it has to be distributed, this edge should not fall closer to the hatch point, then you can modify this. So this is how your set origin command is going to function. So then also we have this matched origin, so that if you click in the source origin and select the object of source, then you can one second, the source for this, then you can match the property accordingly. So this is one option that we didn't explore earlier. So this concludes the hatching of the objects command. So now let's look into the PLINE command. We had dwelt upon this area in the initial weeks, but let us look in more detail now. So let me just select everything and then remove them. Okay, so now you can invoke the PLINE, that is the Polyline command, by typing in PL. So it start off just like the line command. It asks for the start point. Okay, so for quicker understanding, let me also bring in the command prompt to see what are the different option variants. See, the first requirement is the specification of the start point. So once that is done, you can see the next options that are plotted. That is, by default, it will start plotting a line command. So it expects the next closing point. Whereas you can also see the additional options that you have. That is, you can use the option of arc to specify or to continue the next point as a curvilinear element rather than a linear element. Then you have the specification to specify the half width. That half width denotes the width of the next line segment. So that we can edit. That is, we can create a thick line. So that we will see how it option. And next we can also specify the next line segment using the length option. So by specifying the length, a new line segment is drawn using the length at the same angle as the previous segment that we have created. So suppose if the previous segment was an arc, then the new line segment will be drawn a tangent to that arc segment based on the length of the previous arc. So that is your length command. Then we have the undo command to do away with the changes that we done with the most recent line segment added to the polyline. Whereas we also have the width command that will denote the width. So it's a combination of your width as well as the half width. So width denotes the top to the bottom width of your line, whereas half width denotes only the half of the segment. So you can use in tandem within what you require. And also a key point to be noted in the polyline is that this polyline once created can be edited and convert into a spline, that is a smooth spline if required. So that will help us to draw a contour profile kind of thing that will be useful in your advanced drawings. So with key characteristics of this P-line to be taken note is that they can also be drawn with dot dash or complex line types command. That is, you can edit with the line property. Next, as we had looked into the detail, that is, the line width can be made uniform or non-uniform segment. So considering that you have drawn an initial segment with a higher width, and then later you can taper the width as required, that is, you have a non-uniform width to the subsequent length. So then the sequence of lines and arcs that you are using can also use to form a closed polygon or an ellipse. So that also can be done. That is, you are converting this polyline to the subsequent models that you can generate out of the basic line and arc commands. So next, these 2D polylines can be edited to be either inserted or move or deleted the vertices, so that it can be joined to several lines or broken down into its separate constituents. So next, we can also apply the fillet and chamfer commands to these. And also, as discussed earlier, we can turn this as a spline and then also use curve fitting option to use in a 2D polyline. So that option we'll look into the later stages. Next, for this 2D polyline, we can also make use of this calculate area and perimeter command, so that because it is going to be treated as a single object. So that we'll look into the measure option in the later session today. But these are the higher advantages of the polyline command that we can opt for. So just going by, so if the next point length is going to be 150, now what we have made use is that we are extending the line command. That is, the first segment of this P line has been a line. Suppose let's close with the next command of say arc. So then you can make use of all the arc commands that we had looked earlier. So that is, we can either specify the angle based or center based or the direction based. So based on these, we can extend the arc parameters. So suppose if you want to define the center and then proceed, then you can type in or select the center option and then specify the center point, following which now it will refer to the original arc command of center. So the next requirement for that command is going to be your endpoint, and also you can specify the angle and length as an option. So we won't be dwelling into those in much detail, but this is just to give you an idea like how you can combine line and circle together to create polyline segments. So as you can see, this typically constitutes like your spline object. So this is how you build upon it. Suppose if you want to revert back to the line command, then you can click on the L or the line option. So once it's done, then it will go back to the previous one. So now let's look into the length command. So suppose if you are exploring this length, now the length requirement is asked for. Suppose if we are keeping a length of say 200. So now this length of 200 units is drawn with tangent to this arc element. So now let me zoom to the extents, and now let us continue one more line here. But before proceeding, let us try and change the width of this line. So by invoking the W command. So once it starts, now it prompts for the width of the line. Suppose if we want to have a line width to be of say 2 units, and it asks for the specifying the end width, that is it asks for a start width and an end width. So keeping in constant, it will plot a thicker line, whereas if suppose if we want to have a tapered object that we were speaking about earlier, then we can again still invoke the width command. So suppose the starting or line to be of say 5, or to have a better clearer picture, let us say the width to be of 25, whereas the closing the width to be of 1. So now the next endpoint is required for. So let us say it's going to be of a length of say 200 units, and then now let us zoom back. Now you can see you have got a tapered element. So now also instead of the width, you can specify the half width option using H. It again asks for the start and the end point of those the line segment, but rather than the entire width, it refers from the midpoint of the segment. So we can try and create the same thing by using the start width as 12.5 rather as earlier, because earlier we have specified 25. But as you could see, the software considers the previous closing width as the start of this current width. The previous closing width was 1 unit, and hence it carries over the same command and then computes the half of it and returns 0.5. So this is how it's going to work. So now specifying 12.5 to ensure a total width of 25, and then closing width again saying as 0.5 with a length of 50 units. Then see it still starts with the middle and then go about. So it's a uniform object, that is it's a symmetrical object. So using this half width command again, we can try and get the same use as the width option. Now also we have one more command of this PLINE, is that instead of closing the edge manually, we can use this C option, that is close option, to close the object automatically. So now it gets referred to the first start point of your object. So now this object together, even though it has multiple shapes, so let me just turn it off the command line. Now select the object. Now you can see this entire object is selected and is treated as a single object. So if you right click and go into the properties, you can see that it has been constituted as a polyline. So this sums up your PLINE requirements. So now let's look into the Polyline edit option, that is PEDIT option. So that will help us to modify the polylines that we have drawn. So this PEDIT directly opts for different options that are required for editing. That is to either open up the polyline or subsequently close based on the requirement. Next, to join the polyline segments, or specify or modify the width and edit the vertex points, or fit it to a requirement. So next also to modify this as a spline, and then using a decurve option to restore the polyline to its original state as it was originally drawn. Next, the line type generation to generate a line type in a continuous pattern based on the vertices of polyline, and using the reverse option as well as the undo. So we'll look into one by one now. So first we'll explore what is this, why this PEDIT command is used. So this, as we said, is predominantly used to modify the polylines that we have drawn. So we can edit it using the PEDIT, or also using the properties palette or grips, that is editing with grips. We can also that means that if you double select the object, and then this is what you call it as grips, that is based on selection of the grips you can modify the object that you want. So then also the properties that we are speaking about, right click and then changing the properties, wherein we can specify the vertices and henceforth and so on. But this PEDIT command is a comprehensive package containing all the commands. So it is used to move the polyline, edit or delete the individual vertices. that is individual vertex points we can have control over. So next, we can apply an uniform width throughout the polyline segment, or as specified here, we can control individually to each and every polyline segment. So next, we can also create an approximation of a spline called as a spline fit polyline. Next, we can display non-continuous line types that we have seen earlier, that is with the dotted line or the hidden lines, so with and without a dash, before and each of the vertex. Then also, we can change the orientation of text of line type that is assigned to a polyline by reversing its direction. So these are the different modification properties that we can use through the PEDIT command. So first thing is, once you invoke the PEDIT property, you are required to select the polyline. So when selecting the polyline, you also have a dynamic input for multiple. So typically multiple will enable the selection for more than one object. So when we select this option, the edit vertex option will not be available. So suppose if you have to modify the vertex, then you have to go for a single polyline command. So suppose if we look into the multiple and select this object, you can see once the object is selected, you do not have the option to edit the vertex. It is not visible. So let me just repeat it again. So I'm just using a polyedit command and using the default selection for the polyline. So once the default polyline is selected, then we have this option for edit vertex. Whereas if you use the PEDIT command with multiple options selected, then we do not get the vertex edit command. So this is the major difference between a multiple polyline edit as well as the single object selection. So multiple will be used when you are doing the edit option for a group of objects, not for a single one. So now let us go back into the single polyline object and we'll select this object. So once done, we have an option. The first option is the open. That is, if the polyline is a closed one, the current one is a closed one, hence it will ask us have the option to open it up. So if you click on it, you can see that the last command that we used to close up the polyline had been undoed so as to open the polyline. Next, we have got the command for close. So it means that you can close up an open polyline. So this is the first open or close option that is used to edit the polyline segment that is created last for either opening or closing the polyline segment. So next option what we have is a join command. So this join is used to join a line, an arc or any other polyline to a open polyline if their ends are connected or close to each other. So suppose if the ends are not coincident but within a distance, then we can set something called as a first distance. That is, the ends are joined by either trimming them, extending them or connecting them with a new segment. So in this join command, once you select join option, then it will ask for the line. So right now you can see that it doesn't operate because first you have to make this polyline to be an open one. Second, let's see what is the variant of it. So towards that, let us just make this as open. So now we are selecting the single polyline and making it open. So this is done. So now let us consider that we have a single line segment that goes approximately here. So it is something like this. Okay. So in this case, now the objective is to join this segment, line segment, to this P-line and vice versa, and then convert it to be a single object. So for it, in order to use the PEDIT command, if you select the single object, single P-line object, and then go to join, and then it asks for the select objects command again. So when you click on both these points, you don't get any other input. Why? Because for this PEDIT command to work for join, you have to select the multiple objects command. So once you do, because originally what you want to do is you have to join two objects together. So even when executing the PEDIT command, you have to make sure that you have selected the objects of importance to us. So that's why you have to opt for multiple objects and then go about. So now you go on, select the two objects of interest and click in enter. So once it's done, the algorithm identifies that the first object is going to be is already a polyline, whereas the second intended object is not a polyline. So it asks for an option whether to convert it to polylines or not. So let us click on yes to convert it to a polyline. Now let us use this join option. So once you put on this join option, as we discussed earlier, there are two options, that is either to specify the first distance, or we can mention the type of join that we are going to use. So we have three types of joint mechanisms. That is, the first one is the extend, that is, it joins the selected polyline by extending or trimming the segments. Whereas the second one, add, what it does is it joins the selected polylines by adding a straight segment between the nearest endpoints that are available.